Hello, it's a pleasure presenting to you my work on the control of a wind energy conversion system based on a doubly fed induction generator using a fuzzy hybrid controller in case of wide mechanical parameters uncertainties. In this presentation, I will proceed following the present outline. First, I will explain the motivation behind working on a robust controller to overcome mechanical parameters uncertainties. Afterward, I will describe the fuzzy hybrid controller proposed. Then, I will present the simulation results, in addition of comparing these results with other controllers proposed in the literature. Finally, I will conclude the presentation. In response to the rising requirement for energy, a lot of studies have been done to improve the efficiency of the wind energy conversion systems. These studies have found that for each wind velocity, there is a specific generator angular speed in which the maximum mechanical power is extracted as it is shown in the figure in view. The specific angular speed at which the generator must rotate is calculated by the maximum power point tracking algorithm. Hence, a suitable controller is needed to regulate the generator's angular speed depending on the reference value delivered by the MPPT algorithm. The majority of controllers need a complete knowledge of the system's electrical and mechanical parameters for good control performance. However, some degree of uncertainty almost exists in the approximation of these parameters value, whether from an inaccurate approximation or from the aging of the system's components. Few research have been done to deal with mechanical parameters uncertainties. Moreover, some of robust controllers proposed in the literature to overcome mechanical parameters uncertainties have slow response, and a number of these controllers suffer from a persistent chattering in the quantities controlled. For these reasons, the fuzzy hybrid controller have been designed to overcome wide mechanical parameter uncertainties with better performance in terms of time response along with the elimination of the chattering problem. The general form of a controller of wind energy conversion system based on a doubly fed induction generator is a cascade of two subcontrollers, an external and an internal controllers. As we are dealing with mechanical parameters uncertainties, the internal controller will be replaced by a PE controller, while the external controller will be replaced by a fuzzy controller that is an intuitive and robust controller, totally independent of the system's parameters. This is the complete control system. The fuzzy controller has two inputs, the generator's angular speed error and the rate of change in the error. The output of the fuzzy controller is the amount of change in the electromagnetic torque reference. Each of the two inputs and the output has 5 fuzzy sets. The table in view resumes the different fuzzy rules linking the inputs with the output. Simulation of the proposed controller is made in MATLAB Simulink environment. A comparison in the performances of the fuzzy hybrid controller, the classical PE controller, and some controllers presented in the literature is done in this section. 3 simulations have been done. In the first one, the moment of inertia and the viscous friction coefficient are kept to their nominal values, while in the second one, they are increased from their nominal values by 20% and 60% respectively. And in the third one, they are decreased from their nominal values by 40% and 60% respectively. The controlled angular speed in the first simulation is presented in the figure in view. In nominal conditions, the proposed controller is 3 times faster than the classical PE controller. The controlled angular speed in the second simulation is presented in the figure in view. As we can notice, there is no persistent chattering in the angular speed. In the conditions of the second simulation, the proposed controller is 3.5 times faster than the PE controller. The controlled angular speed in the third simulation is presented in the figure in view. As well, there is no persistent chattering in the angular speed. In the conditions of the third simulation, the proposed controller is 3.6 times faster than the PE controller. To evaluate better the performance of the proposed controller, a comparison has been made with H infinity and Cron controllers presented in the literature. The fuzzy hybrid controller is found to be 5 times faster than the H infinity controller and 3.3 times faster than the Cron controller. To conclude, the fuzzy hybrid controller proposed is a robust controller and sensitive to wide mechanical parameter uncertainties. It is characterized by its faster response and its ability to eliminate the persistent chattering from the quantity controlled. Thank you very much for your attention.